this is Jean Bedourde. Today I'm going to cover different types of classification systems and how they are implemented in the online environment. Let's start from the beginning. Classification is divided into physical stuff and logical classification. A physical object needs a unique storage location. Then there has to be a way of finding that object again, whether it's a book or a piece of paper or a painting. Libraries use the Dewey Decimal System and the Library of Congress system to put books on shelves so they can be found again. Same with archives and museums. They need a way of organizing physical stuff. On the other hand, a logical scheme allows for multiple classifications. These exist separately from the physical object. Indexes, whether they are print or online, are logical. The traditional card catalog is a logical classification with the subject indexes and cross-references at the bottom. These logical classifications are very powerful in the online world because subject headings can be used to search entire databases. Much faster and easier than the old-fashioned manual techniques. A key takeaway from this unit is that the different types of classification schemes. Each organization tends to have their own way of organizing stuff. That's what filing systems are all about. Everyone files paperwork differently. On the web, vocaularies were touted as the latest and greatest innovation. But turns out, most people are lousy at categorizing, so the fad died out. What has remained is the use of tags, and they're actually quite useful. For example, in Delicious, I use 244 to tag websites that I'm going to use in this class. Controlled vocabularies are the most common type of classification and the most useful. They are needed in online databases because you can't use physical location to find similar objects. On the web, controlled vocabularies are absolutely crucial in setting up categories for navigating websites, but the logical relationships may actually exist as an Excel spreadsheet. Thesauri, also known as taxonomies, are a major step beyond controlled vocabularies. They require a different level of analysis and reference and are accessed using separate indexes. There's so much more work involved in the software development side, so relatively few databases have thesauri. I'll just introduce you to thesauri and taxonomies in this course. They are another information specialty you may want to explore. Classification systems are the bread and butter of experienced researchers, but they are not perfect. In the introduction to aggregated databases, I discuss their evolution. There are issues with decades of development. Over time, new terms are added to classifications and old ones become obsolete. In a library, books are not recatalogued. Same situation for a database. Subject classifications attached to a record are not changed when new terms are added. Cross-referencing is added as much as possible, but as a searcher you need to be aware that terminology may be different for older material. On ProQuest Dialog it's quite easy to do cross-file searches, but you need to be aware of subject-specific vocabularies. This is most common in medical, engineering, and the life sciences. Vocabularies get really specific. The Mesh Thesaurus from the National Library of Medicine is the gold standard in the medical community and gets updated every year. The annual reload is a massive process. However, human lives are involved, so your government funding makes this happen. Most databases do not have this level of funding and commitment, so database publishers seldom retrofit their databases. Classifications are unique to subject areas and also vary by database. Embase, Biosis, and Medline are often searched together, but they have differences in their classification schemes because they're produced by different vendors. Generally, databases produced by the same publisher will share the same scheme, but this too can vary. Now let's examine implementation of classification systems. As you look at a record, you will see that there are different fields. You're familiar with bibliographic citations, which are a type of metadata, but metadata can be much broader. Patent databases have a number of different dates, such as application date and grant date, both key. Geographic coordinates are used for mapping. Store locations require a street address. What's key is that the values in these fields are unique for each object. Classification systems, however, allow for multiple fields and often multiple values. To get a better understanding, look at the subject fields at the bottom of the record when you retrieve an article. As searchers, you may find idiosyncrasies that don't make sense. That happens. There are changes over time as new terminology and new technology is introduced. Just think about the field of computers and computer science, or the changes in popular culture. That's part of the art of searching. There are also not so obvious aspects. There's human judgment in setting up indexing terms, and we don't all view the world the same way. And software changes can also impact automated assignment of subject terms. One aspect that won't be documented is changes in editorial policy. For example, an abstract database may have different indexing when full text records are added. Editorial policies are just another aspect to continue to consider if you get unexpected results. So what are the best ways to utilize subject descriptors? The first step is to look at the pro sheet for each database. This lists the individual fields. A number of these will be classifications of some sort. The next step is to look at a full record related to your topic. Look for the subject descriptors at the bottom of the record to get a sense of the fields and the values that you can use for searching. If a thesaurus is available, you can use this to discover synonyms and additional search terms. Keep track of your search terms in a log. You can then use the same search terms on the open web or full-text databases. Also, keep in mind that you can get different results from the same data implemented on different search platforms. Just part of being a professional searcher. Moving on, so far I've emphasized databases that originate in the nice, tidy world of abstracting and indexing. But there are many other types of information. So I'm using the patents database to illustrate some of the complexities of these other types of information. Plus, it's readily available as a government database. Government documents started out as pieces of paper. The forms and processes were developed long before electronic databases and search engines. Yet the information is still essential. The older patents from 1790 to 1975, almost 200 years, are available only as page images. The text can't be searched. From 1976 on, the full text is searchable. As you explore the database, the fielded data will be familiar to you. There are titles, patent numbers, dates, companies and inventors, as well as classification codes. However, patents also involve long descriptions with wordy claims. Patents also have images, which from a technical standpoint are very difficult to load into a database. They are also challenging to retrieve and display. It's significant that Google has a separate index for images. A patent application also has links to other patents, which can be prior art, patent families, or applications filed in other countries. These relationships can be quite complex, which is why patent searching is a specialty. Patents are available on multiple search engines, each with different features. Interestingly, The examiners at the Patent Office prefer the powerful search engine provided by ProQuest Dialog over their own search engine. As you explore this module, keep in mind that classification systems have two aspects. One aspect is developing the structure, which is a very specialized job. The other is utilizing these systems for your power searching. That's what we're exploring in this class. Now let's go explore their capabilities.